We're looking at the model for federal hourly minimum wage from the years 1938 to 1997. So as you can see, it increases, but not at a constant rate. So we can't use a linear function. It's either going to be quadratic or exponential. Since we've already done quadratic, we're going to do exponential. So here we go. In Desmos, since 1938 is 8 years after 1930, this just makes the arithmetic easier. And then 1997 would be 67 years after 1990. So just think of it this way. Somebody who's born in 1930 would have been 67 years old in 1997. So I changed my axes so that these would be the years since 1930 for the x-axis, going by tens, and from 0 to $6 along the y-axis. So go to the end of your data. Make sure it's not highlighted. Hit enter once, it stays in table, enter twice, and now you're still within the folder if you made a folder. So let's see, I think this was Y3. Indeed it was. So the model Y sub 3, if you just type 3, that's all it does. Tilde A is going to be our coefficient. B, if you remember when we did exponential functions, B is our base. I'm going to put it in parentheses. And then raised to the x3 power. So you'll see it created our function. Here's our purple curve. And it's a pretty decent fit. You can see our r squared here is 0.9747. So our actual equation would be y equals 0.373. We'll stop there. And then in parentheses, our b value 1.04 should be good enough, raised to the x power. And you can see pretty good fit to the other one. I got a few decimals, and you can see it stretches out a little bit, becomes a little bit, well, you can see a little bit of daylight between the purple and green, but actually a very good fit for this set of data.